Introduction to contiguous pile. This wall method is often used in permanent application as retaining wall in basement excavation or tunnel where walking space is limited or adjacent existing structure require restraint. Structural piles are installed in close spacing, typically with 100 mm gap between piles. This method is suitable in wide variety of soils where groundwater lies below the maximum excavation depth. The reason of this project using contiguous pile is due to immediate vicinity of dense surrounding traffic such as monorail station, existing building, and so on. The first step of the construction process is setting out. First of all, a licensed surveyor will set out the positions of ball piles as shown in the pile layout plans. Wooden pegs are used to mark out the center position of each ball pile, and the gap between two ball piles is normally between 100 and 200 millimeters. After that, the installation of casing. The vibro hammer drives a casing into the ground, leaving approximately a meter long of casing protruding out the ground. The casing is ensured to be installed plumb and perpendicular in order to maintain the stability of ball piles. It must be strong enough to withstand the ground stress as well. The bore hole is excavated around the perimeter of the excavation level alternatively, where the primary panel will be excavated first, then the secondary panel.
The auger, a drilling tool, cuts and removes the soil within the casing to form a borehole. The soil is trapped between the flats of auger. soil surrounding the borehole is supported by the casing. If the casing is not long enough to reach the required depth in the ground, bentonite slurry is poured into the hole to act as a support to the soil below the casing. Bentonite slurry is a combination of volcanic ash and water that grows and expands when wet. Bentonite circulation channel will be made from borehole to bentonite tank, and fresh bentonite slurry will be pumped into the borehole through hose pipes. At enough high concentration, bentonite suspension will begin to take on the characteristics of a gel. This expansion allows it to permeate cracks and crevices to form a solid barrier against the soil pressure. At this stage, a reinforcement cage is inserted in the pre-bore hole by crane. Reinforcements shall be free from rust and mud and shall be sufficiently rigid to ensure that they remain at their correct level during the lifting and placing of the concrete. Also, concrete spacers are provided to prevent rebars from contact with soil and prevent corrosion. This also protects the rebar from fire for a certain duration of time and helps to provide proper transfer of stress from concrete to steel rebars. Concrete is then poured into the borehole to form the bore pile by using Trimai method. The Trimai tube sections will be inserted and be jointed until it reaches the bottom of the pile shaft. This is to bring the concrete through the pipe of the interior of the concrete being poured, thus preventing contact with the surrounding water. Before concrete is poured into the Trimai tube, a plug that keeps the concrete separated from the water is placed in the pipe. When there is sufficient concrete to displace the plug, then the concrete will start flowing into the hole.
The next step is Trimai tube removal. After the concrete reaches a cut-off level, the Trimai tube can then be extracted piece by piece as the concreting goes on. This type of pile is a replacement pile since the soil is taken out and replaced by concrete. The Trimai tube need to remain at fresh concrete when extracting. The following step is the extraction of casing. When the concrete is hardened, the casing is ready to be removed. The vibro hammer extracts the casing from the ground. The casing is ensured to be extracted straight to prevent certain problems to concrete, such as necking or diameter narrowing.
After that, excavate the secondary boreholes. The procedure of the construction of secondary bore piles is the same as primary bore piles. The gap between the primary and secondary bore piles is filled up with cement mortar. Also, whip hole, which is made from PVC pipe, is installed at the gap to allow the groundwater to flow out in order to prevent excessive groundwater pressure. Tieback is installed to support the bore pile. This additional support is driven by hydraulic jack. Tiebacks are constructed by drilling a small diameter shaft into the ground behind contiguous bore piles. Steel tendons are inserted into the shaft. Also, grout is pumped into the shaft to anchor the tendon as the drill casing is retracted. Basically, tieback is installed with walling. Walling is to reduce the number of tieback required and also support the soil.
After the construction of contiguous bore piles, cap beam is installed on top of bore pile. It is to hold all the bore piles together and increase the stability. Lastly, a 200mm thick reinforced skin wall is installed in front of the exposed bore piles for aesthetic value. The reinforcement bars of skin wall are tied to the main bars in bore piles. Contiguous bore piles with skin wall constructed in front is used as permanent basement wall. Conclusion: contiguous bore pile is the most suitable supporting system for this project because it is suitable to retain stiff and cohesive subsoils where groundwater levels are below the eventual depth of excavation. Also, this technique avoids excessive excavation and assists in the control of ground movement.